Welcome to Emtron ECU Training Part 62. In this training tutorial, we're going to be taking a look at our Advanced Nitrous Control programming. In our Advanced Nitrous Control, we're going to be introducing working with progressive style nitrous control, working with a solid state relay, and pulse width modulating a nitrous control solenoid. This gives us the ultimate way to control our nitrous because we can vary the amount of nitrous we're going in and flowing into our engine, so we can vary or stage the amount of power production our engine is going to make. This allows us to gain traction on a traction limited vehicle and be very specific of how we want our nitrous to be ramped in versus our engine speed. So we'll essentially be controlling our engine's torque production and not being as harsh on our engine when that nitrous turns on. We're gonna have a lot to cover in this tutorial. Let's jump in so we can check out working with our advanced style nitrous control. Okay, so let's get started. We're gonna be taking a look at working with our progressive style nitrous control and tuning within our Emtron ECU. Our progressive style nitrous control allows us to vary how much nitrous we're spraying into our engine with a given orifice or jet size. So for example, if we have a 200 shot of nitrous and progressive style nitrous control, we could deliver 50, 100, 150, or even up to 200 horsepower worth of nitrous flow, whatever the orifice or jet size is going to be rated at, in this pulse width modulated progressive style format. It gives us the ability to ramp in the nitrous so we don't have a large spike in the engine's torque, a little bit easier on the engine. We also can have this progressive control where we want to ramp in nitrous with, let's say, something like ground speed or a timer that allows us the flexibility to bring in the power so we don't go into wheel spin when we're launching our car, let's say at the drag strip. So we have a lot of things we can accomplish with the progressive style nitrous control that we really can't accomplish with the on-off style control, even in multiple stages. This will have a lot greater flexibility. It gives you a lot better modulation over the engine's power when we're spraying nitrous. Let's dig in here. Let's talk about how to set up a progressive style nitrous control. It's actually relatively straightforward. There are a couple details that we need to know in order to program this properly. Now, just to make sure we're having everything as condensed and consistent as possible into one tutorial, I am going to go over the basics of the difference between dry and wet, fogger versus direct port. So we have all that established here in the beginning of the video. We did cover this in the previous tutorial with the basic on-off style nitrous control. I want to make sure we're having all of the information in this video if you chose to skip over that last video, so you don't have to watch both of them. So very quickly here, let's run over the differences between the different types of nitrous kits we might be running into and the advantage or disadvantages to what we're finding here. So coming up on screen right now, I have two different pictures. I have a dry and a wet kit. Now this is a single fogger. As we can see here, we have our nitrous orifice that we're finding in either situation. It's mounted onto the intake. Now in this situation with a dry, we're just spraying nitrous. With a wet, we're spraying nitrous and fuel, which is where it gets the wet terminology from because the fuel is spraying with the nitrous. When we're dealing with a dry single fogger, as we're looking at this particular picture here, we're gonna find that we do need to raise the amount of fuel we're spraying into the engine. We're bringing in greater airflow, and therefore we need to have more fuel to match this. Now we're going to be spraying the additional fuel we need through the port fuel injectors. So the Emtron is going to be programmed to recognize the amount of nitrous that we're spraying and ingesting into the engine, and it'll figure out mathematically how much fuel we need to go in and raise or how much pulse width need we increase to our fuel injectors based on the fuel injector flow rate size in order to make sure we have proper and safe air fuel or lambda when we're going in and running with nitrous. Now, looking at the wet, we're spraying our fuel here in a mechanical style jet. The relationship between the fuel and nitrous, so the ratio that we're going to be finding there, that's all controlled mechanically through the jet sizes. So you'll have to jet the fuel jet to the size relationship to the nitrous jet you're going to install in that nitrous spray nozzle in that fogger situation. So we're not spraying the additional fuel through the port fuel injectors. We're spraying it mechanically through that spray bar, that nitrous spray bar going into the intake in this configuration. And it will be jetted in a mechanical type of situation, and the air fuel or the lambda when we're spraying nitrous is controlled through that relationship through the jet sizes between the fuel jet and the nitrous jet. So we need to make sure that those are correct. And when you're purchasing the jets from a nitrous company, they'll tell you what jet size to run for the fuel in relation to the jet size to run for the nitrous that you're spraying. All right, so now that we understand the differences between a dry and a wet, and we're looking at these pictures here, again, we have just our nitrous nozzle spraying the nitrous or spraying the nitrous and fuel into the intake manifold, and this is known as a single fogger setup. Now, a single fogger setup, whether you have a 4-cylinder, 6-cylinder, 8-cylinder engine, it doesn't really matter. We don't want to run much more than 100 shot of nitrous, although people have, and people claim that there's no issue with this. The problem is going to be when you spray nitrous through the intake manifold. So it has to distribute through the airflow path through the intake manifold. We're going to find that it doesn't evenly distribute between all of the cylinders. We might find that one cylinder gets more nitrous than the other. In that situation, that cylinder will run leaner than the others. That leads to potential knocker pre-ignition over time. We want to make sure if we're spraying a large enough shot of nitrous that we're moving to a direct port style nitrous control where the nitrous nozzle will be mounted one per cylinder or one per runner on the intake manifold. We'll find that's going to make sure that the nitrous is distributed evenly between all of the cylinders. This proves consistency. This also improves reliability because there's less chance for it to knock or pre-ignite because each cylinder is getting the exact amount of nitrous shared equally between all of them. Okay, so now what I want to do here is just go and take a look at our next picture. It's just going to go over just conceptually here the difference between our single fogger and our direct port. Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.